we had stopped at looking at deviation produced when a light ray is incident on no reflecting surface. We looked at something related to this as a review. That if I have this I here, I have this R here. We said that if this is the angle of glancing, that the deviation D produced can be given by twice G. Is that okay? So, having looked at that, let's see how we can basically use this ahead. And then that is the deviation after two successive mirrors inclined at an angle. So we are going to look at deviation after two successive reflection. Here I am supposed to put the word reflection on a mirror. Deviation after two successive reflection on a mirror inclined at an angle. That supposing we have two mirrors which are inclined at an angle, say theta, what is the resultant deviation of the light rays that is produced? Then let's consider, we can say, consider an incident, light ray on no mirror M1 and reflected to mirror M2 as shown below. Is that okay? So we are trying to look at an incident ray, a ray which is incident on a plane mirror, the first mirror, and then it is reflected in the second mirror, and then the second mirror will reflect it away as shown below. Let's have a simple sketch for that. If I have this as my mirror M1, okay, and then I have this is M1 and then this is M2. Is that okay? Now, if we consider a light ray which is incident, is that okay? It is incident on the first mirror, and then it is reflected here to the second mirror. Is that okay? And then the second mirror reflects it in the other direction. Is that okay? Provided that the mirror has been inclined at an angle theta. That is exactly what I was talking about. That if I have a light ray, I can name it and say this is O, I can name A, and then B, and then C, and then D. Okay? And now I can also say, supposing when it is incident on the first mirror, it's making an angle of glancing, say, alpha. Is that okay? And it is very true from our proof we made behind that, this angle can also be alpha. Is that okay? This is the reflected ray for the first mirror, but it is an incident ray for this mirror, that on this mirror it is incident, it is just going. But for this mirror here, it is leaving it, therefore it is reflected. Is that okay? Now, if it is incident at an angle, say beta, okay? I'm calling that angle beta. It is also very true that this same glancing angle can also be beta. Is that okay? And then, it is also very true that this ray as it was coming, it was supposed to move in this direction, but later on change direction and is now moving in this direction. Therefore, how do we call the angle between the initial direction and the final direction? The angle is called the angle of deviation, that I can say it deviated for the first time, therefore D1. Is that okay? That it changed direction, it was moving in this direction, but it changed now. The angle between the direction it was supposed to move and where it's now going is what you're calling angle of deviation 1. Is that okay? And then, when it also came here, it was supposed to continue in this direction, but it finally changed the direction by reflection, and now we can also say this is another deviation I can call D2. Is that okay? So that means that if the ray is incident on the first mirror, reflected and reflected, it is deviated how many times? It is deviated 2 times. Is that okay? D1 on the first mirror and D2 on the second mirror. Is that okay? And it is very true that considering reflection, considering reflection in mirror 1, or I can say in mirror M1, because I've named it M1. And then we know on mirror M1, angle of glancing is in alpha. Is that okay? We are aware that from the proof we have just made that if a light ray is always deviated, the deviation is always twice the angle of glancing. Is that okay? We have just looked at that deviation is always twice angle of glancing. Is that okay? So that means we are right to say that this deviation D1 here that you're seeing, D1 is twice angle of glancing. What is angle of glancing? The angle between the reflecting surface and the incident ray. Is that okay? And that angle on our diagram is alpha. Is that okay? So I can call this one also equation 1. Are we together? So, if that is that, and then we can also look at the reflection on mirror 2. Reflection in mirror 2. In mirror M2. In mirror M2 here, we are saying that it is incident but on mirror 2, but the angle here we are having as the angle of glancing is angle beta. And therefore, we can say that deviation in mirror 2 is given by twice the angle of glancing, which is equaling to beta. Is that okay? So therefore, deviation here is twice angle of beta. And then we are saying that our interest is what is the total deviation, because the deviation we are looking at is for one mirror. That mirror 1 produces twice alpha, and then mirror 2 produces twice beta. Now, what is the total change in direction? That initially it was moving in this direction, and now it is moving in this other direction. What is the total angle? This, the total deviation. Is that okay? Which is the same as this, which is the same as this, this is the same as the D1, this one here is the same as D1, and then add this, which is the D2. Isn't it? This is the D2. That it is this plus that. This and that. You know this, I can also call it here as that. So plus that, I get the total deviation. Therefore, I can say total deviation D is given by D equaling to D1 plus D2. Is that okay? So therefore, if I call this an equation 2, this one equation 3, I can say substituting equation 1 and equation 2 in equation what? In equation 3. I'll get total deviation as a twice beta, twice alpha plus twice beta. And then I can say deviation is twice into alpha plus a beta. Is that okay? Are we together? And then if we can consider triangle, from triangle B, if this is my point O, B or C, this triangle here, it is very true that angle alpha plus beta plus theta, total angles in a triangle adds up to 180. That means this plus that should be equaling to 180 degrees. Is that okay? And it's true that alpha plus beta equaling to 180 degrees minus theta. Is that okay? Bringing back here, we can say D equaling to twice into 180 degrees minus theta. Is that okay? Is that okay? So, after looking at that, I can now reopen this and say D equaling to 360 degrees minus twice theta. But in which direction did we measure this deviation? We measured this deviation in this direction. And what is this direction that I'm trying to show? That is a clockwise direction. So deviation is 360 minus 5 theta, clockwise direction. Clockwise direction. Is that okay? Is that okay? Now, supposing you are asked now to find it in anticlockwise. How do we get it in anticlockwise? To get it in anticlockwise, we shall say D is equaling to 360 minus the one in clockwise. 360 minus twice theta. Is that okay? And that is 360 degrees minus 360 degrees plus twice theta. That means deviation is twice theta, and this is in now anti-clockwise. Is that okay? So there are two ways of deriving it. I can derive it in clockwise direction, and I can derive it in anti-clockwise. Is that okay? So I'm saying if I derive it in clockwise, to get it in anti-clockwise, I can now say the total 360 minus. So like take an example. If I have something like this, if I've measured this angle as theta from here in clockwise direction, if I want to know it in anti-clockwise, I will say it is 360 subtract away theta. Isn't it? Now that will be measured from this other direction. Is that okay? That if I measure it as theta in clockwise, if I want it anti-clockwise, I say the total angle, I subtract away what I've measured, and then it will move now in anti-clockwise. And that is exactly what I've done here. Is that okay? Good. So, having looked at this, let's try looking at an example of this as an application of what we have looked at. Because what is very true is that an arrangement of two mirrors inclined at an angle forming multiple images forms what we are calling a kaleidoscope. So, let's meet